All right, we're back here for part 3, video 3. So we're on the last page here. This is actually part 4, properties of functions. There's a lot of vocabulary when we talk about functions. And when you hear this vocabulary, you need to ask yourself, is this referring to the x value or to the y value? Domain or range? So when you hear the words, we need to be familiar with them so that we know where we're looking or what we're trying to find. So number 5, use the following graph to determine the properties of the function. So here's the function. All right, we've got this shape here. There's really 3 parts to this. If I go from left to right, which is usually how I want to look at this, so we start down here. Notice that we rise. If we're thinking slope, this would be a positive slope. And then in this middle section here, this is horizontal. The slope is 0. So the y value doesn't change. We don't go up or down. And then in this last section, from left to right, we are going down. Okay, so domain. Domain is the x values. When we're looking at a graph, we read that from left to right. Now the farthest point on the left is here. What's the x value? Okay, domain is x. So that would be -5. How far do we go to the right? Well, we end here, and this number, it's not written, but we know that's a 6. So we go from -5 to +6. Domain, I'm going to use interval notation. So -5, comma 6. Now this is not an ordered pair. This is not the point, -5, 6. This is an interval. Notice this is an open circle here. That means that -5 is actually not part of the domain. It starts there, but it doesn't include that. So I'm going to use an open parenthesis, what I call open. An open parenthesis. That means that that number is not part of the solution. Now 6, though, is a closed circle. So I'm going to use a bracket to represent that. A bracket means that that number is part of your answer. Now again, this is called interval notation. If you prefer to write it in inequality notation, you can, but just to show you, the domain would be the set of x's such that, I put a little slash there, and then it's -5 less than x less than or equal to 6. Now the reason I only put a less than is because -5 is open, it's not included. And then for the 6 I put less than or equal to because it's closed, it's part of the solution. Okay, but look how much longer that is. We don't want to do that. So the domain, those are your x's. The range is the y values. So now we're thinking lowest to highest. Domain is left to right. Lowest to highest. Okay, so our lowest value is here. The y value, because it's range, is -4. And then the highest value is here, which is +2. And notice we get that value quite a bit. All right, so from -4 to +2. Now -4 is open. And then +2, now that point is part of the function, so I'm going to close at 2. I'm going to put a bracket there. So that is our range, -4, 2. X-intercepts, that's where we touch the x-axis. You'll also see those called zeros. So if we look at the x-axis, it looks like we touch here at -3 and here at +4. So the x-intercepts are at -3, 0 and +4, 0. Now notice, these are not intervals, these are ordered pairs. So we need to differentiate between, when it's domain or range, we're talking about a set of values. When we're talking intercepts, these are specific points. The y-intercepts are where we cross the y-axis. That's right here. It's 0, 2. All right, now increasing, decreasing, and constant. If you think about this in terms of slope, increasing from left to right is going to go like this. Decreasing would be a negative slope from left to right. Constant would be horizontal for that. All three of these, increasing, decreasing, constant, we write them with the x values where that's happening. Okay, so this is where it gets a little bit confusing sometimes, because when we talk increasing, that would be this first section here. And we think of that, well, from left to right, our function is rising. We're going up. But we're not going to write down what the y values are. We want to write down where do we start rising and where do we stop rising. And when we do that, what we're looking at is the section, the x values where that happens. So we're going from -5 to 2. This is the increasing section. We start at -5. We rise until we get to here, which is at -2. So increasing, we're going to write that as a interval, -5 to -2. With these, we're always going to keep them open parentheses. The reason we're going to do that is that when I get to -2, I'm not rising or falling or constant. So I'm not including that. I'm not rising during that time. Okay, so for domain and range, we do need to say whether it's open or closed. But when we're increasing, decreasing, or constant, we're going to keep those open. Now decreasing, well, actually, let's do this. Let's go from left to right. So in this first section, that was increasing. Then, so we stopped at -2. So let's start up again. From here to here, this is constant. It's horizontal. Now, what are the x values where that happens? It's from -2 to +2. That would be constant. And then the last section, so here's increasing. Here I can label that constant. And then the last section, now we start here at +2, and we fall, we decrease until we get to +6. So our interval from left to right is 2 to 6 for decreasing. The temptation is to write what the y values are, but that's not how we do it. Increasing, decreasing, constant, we're talking about the x's. So let's do one more example, okay? And this takes a little bit of practice to get used to reading it. Number 6, use the following graph to determine the properties. Now this is kind of a different shape here. As we go to the left, notice that we have some arrows here. And then also on the right. That means we're not stopping. Arrows mean we're going to keep going to the left forever. And then here, we're going to keep going to the right and going down forever. So we're going to have to be able to write that. Now domain is x's, so we're thinking left to right. Well, how far left? We're going to keep going to -infinity. And then we come through. How far right? Well, we're going to keep going to the right. So the domain is -infinity to +infinity. All right, now the range is the y values, so lowest to highest. The lowest value, well, we're going down here, and we're going to keep going down. So that means our lowest will go to -infinity. Now, how high do we get? Well, our highest value looks to be right about here. That looks like 5. And since that is a value, we're going to close that. One of the things about the infinities is we always keep those open because infinity is not a number, it's a concept. You actually never reach infinity. It's not a number, it's just an idea that we keep going and going. All right, now the 0 is the x-intercepts. Well, definitely looks like there's an x-intercept right here at positive 2. So that's 2 comma 0. On the left side, let me kind of explain what's happening here. Notice that as I go to the left, this curve gets very flat. And we're going to look at functions later on in the year where this curve is going to get closer and closer to the x-axis, but it's never actually going to touch. When you see it do this, we are going to assume that it doesn't actually touch or cross over here. So in this case, there's only one x-intercept. Do we have a y-intercept on the y-axis? Yep, we do, right there. There's the y-intercept. That is 0, comma 4. All right, now, increasing and decreasing. Those are x values we're going to look at. We're going to go from left to right. Well, now how far left do we go? Because of this arrow, it's all of this. It's going to keep going to the left. Now this first section, though, from left to right, we are rising, we are increasing. So our increasing is from negative infinity. Okay, I'm going to do this. I like to shade my number line, my x-axis, because I think it makes it easier to visualize what's happening. So remember, we're going off the graph here because of the arrow. So that's from negative infinity. Now where do we stop increasing? Where do we turn? Right here. Now that's not 5, it's the x value minus 1. So minus infinity to minus 1, this whole section here is increasing. Then we turn, and then the rest of this graph is going down. So we are decreasing. Now we start from left to right. We start here at minus 1. And because of the arrow, we keep going forever. So this whole section is our decreasing. That is from minus 1. Now it doesn't go to 6. It keeps going from minus 1 to positive infinity. All right, and 2 more concepts, and then we're done here. The last 2 concepts are what we call end behavior. End behavior. In other words, what happens at the end? As we go far to the left and far to the right, what's the graph doing? Now, both of these are y values. The end behavior, what we give is the y values. Now, here's how we read this. As x, arrow negative infinity. As x approaches negative infinity. In other words, as we go far to the left, what happens to f of x? And remember, f of x is the same thing as y. As we go further and further to the left, what's happening to the y values? Well, the y values are at 5, and then they're coming down as I go to the left. Now remember, the way that this graph is flattening out, the curve is flattening out, that means that we're going to get closer and closer to 0 without ever getting there. We're never going to get to the x-axis. The y value approaches 0. It doesn't mean that we get there, but it means that we're saying that y approaches 0. So that's the end behavior to the left. Then we have as x approaches positive infinity. So in other words, as we go to the right, the y value is approaching, so f of x is the y value. Well, we're going down, and we're going to keep going down. So what's the y value we're approaching? Negative infinity. That just means we keep going down. So the end behavior is talking about what happens to your y values at the ends. The increasing, decreasing constant is what are the x values where we're going up, going down, or staying constant. And that is the end of the notes.